Good afternoon, sir.
Sir, Bhaskar Babu, sir. Namaste, sir.
Namaste, Achari.
So,
Namaste.
we are eagerly waiting for your wonderful presentation.
Thank you. So, principal is joining?
Yes, sir. We are waiting for sir.
Fine.
Once
Okay.
he joins, we start the program immediately, sharply at our prescribed time.
Okay.
Bhaskar Babu, good afternoon.
Good afternoon. Good afternoon.
Sir, please start the problem, sir. Already principals are joined, sir.
Okay. తెలియదు మరి సార్ ప్రిన్సిపల్ గారు జాయిన్ అయ్యారండి
Join here, sir. Already sir has
Good
joined.
afternoon, sir. Join in, sir. Sir, TSS and
good
join
afternoon,
in.
sir.
Good afternoon,
Good
sir.
afternoon, sir.
Sir, good afternoon, sir.
Good afternoon, sir.
Good evening to all the participants and a warm welcome to the 1-week international FDP of mathematics. This program being organized to celebrate the 104th birth anniversary of the great mathematician Professor Komarvallu Chandrasekharan Garu and the 70th birth anniversary of our former HOD Professor Nagala Prabhakar Rao Garu. The goal of this FDP is to update the faculty members on the latest advancements in the fields of graph theory, linear algebra, functional analysis, machine learning, statistics, and their applications. Now I request one of our staff coordinator, Sri N. Karunakar Garu, to take over and complete the program.
A very warm and healthy good evening to our respected principal, Dr. Nazir Sheikh Garu, Principal, Vapatla Engineering College, our beloved head of the department, Dr. Kevil Nacharil Garu, Department of Mathematics, Vapatla Engineering College, Vapatla, my dear colleagues and participants. It is my pleasure to welcome you all on the occasion of birthday celebrations of great mathematicians, Dr. Komarvallu Chandrasekharan Garu, 104th birthday celebrations, and former head of the department, Dr. Nagala Prabhakar Rao Garu, 70th birthday celebrations from the soil of Bapatla. These eminent scholars have made remarkable contributions to the field of mathematics through their prominent research and innovative ideas. In honor of their invaluable contributions, the Department of Mathematics, Vapatla Engineering College, in association with Institutions Innovative Cell, is organizing a 1-week international faculty development program on innovative applications of mathematics, IAM 2024, through virtual mode. This program is scheduled every day from 3 p.m. to 5 p.m. from 18th November 2024 to 23rd November. More than 800 faculty members have registered from various education institutions across the country for this faculty development program. Now I request one of our staff organizers, Ms. I. Rajeswari, to present the department profile.
Good evening to all. The
Good evening.
department was established in the year 1981, in which the college was started. The department, which was originally intended to cater the needs of engineering.
Madam, your video just turn off so that signal strength will be good. Turn off your video.
Field of mathematical research and honored with many awards and rewards. He authored 5 Dr. KVLN Acharlu sir edited more than 150 and editor-in-chief airs journals and international level with 850 participants successfully. And also conducted an international successfully. This year in the coming months. Thank you.
Thank you, Rajeshwari, for sharing our department profile. I would like to bring to our kind notice on the objectives of this faculty development program to encourage a culture of lifelong learning among the faculty by motivating them to stay with the latest research, educational needs, and creative methods for teaching mathematics. To promote interdisciplinary approaches among faculty by showing how mathematical ideas can be applied in different academic fields and real-life situations. To serve as a cornerstone for continuous improvement and enhance faculty knowledge with innovative teaching methods. Brief information about this International Faculty Development Program. On the first day, that is today, 18th November 2024, Dr. J. Bhaskar Bapuji Garu, Professor, Department of Mathematics, Anna University, Chennai, will deliver graph techniques for cyber security. On the second day, 19th November, Dr. C. Pavan Kumar Garu, Faculty of Mathematics, Apex Max Excel, North Carolina, USA, will deliver a talk on linear algebra tools and its applications. On the third day, 20th November, Dr. KVV Varaprasad Garu, Associate Professor, Department of Mathematics, Guru Ghazidas Viswavidyalaya, a Central University, Bilaspur, will deliver a talk on iterative procedure for approximating field points in contractive type mappings. On the fourth day, 21st November, Dr. P.V. Sundarant Garu, Professor and Head Department of Mathematics, Rayalaseema University, Kurnool, will deliver a talk on optimization problems in machine learning. On the fifth day, 22nd November 2024, Dr. N. Sudhakar Garu, Professor of Computer Science and Engineering, Bapatla Engineering College, Bapatla, will deliver a talk on binary classification using precision. On the last day, 23rd November 2024, Dr. G. Srinivasarao Garu, Department of Mathematics and Statistics, University of Dodoma, Tanzania, will deliver a talk on basic statistics and nonlinear optimization using R. Now I request our head of the department, Dr. KVLN Acharya Garu, to address the participants on this occasion.
Good evening to all. On behalf of Department of Mathematics, I warmly welcome you to this international FDP. It is an honor for me as head of the Department of Mathematics at Bapatla Engineering College to speak few words in this faculty development program, which is being held in view of birthday anniversaries of Professor Komarvolu Chandrasekharan Garu, Dr. Nagalla Prabhakar Rao Garu, two renowned mathematicians. Both of these scholars are from the soil of Bapatla. Bapatla is a place known for its rich cultural, literary, spiritual, dramatic, and educational heritage. Professor Chandrasekharan Garu brought great recognition to Bapatla with his contributions to mathematics, and his valuable research work is a source of pride for us. Former HOD Dr. Nagalla Prabhakar Rao Garu also made significant efforts to strengthen our department through his dedication and systematic execution. We pay our heartfelt respects to Professor Chandrasekharan Garu, Dr. Prabhakar Rao Garu for their remarkable contributions to mathematics. I also want to take this opportunity to express my gratitude to our supportive, magnanimous management, Bapatla Education Society, for their encouragement in conducting various academic programs. I extend my sincere thanks to our beloved principal, Dr. Nazir Sheikh Garu, for his guidance, continuous support. Under his leadership, our college received NAC A+ and NBA accreditations for several branches, and we are truly grateful for his valuable and tireless efforts. The main goal of this international FDP is to focus on innovative teaching methods and best practices. It aims to help our teaching community for exploring new ways to engage students, improve critical thinking, and adopt new logical approaches. FDPs also support faculty in their research, which helps maintain the quality of education and boost motivation and confidence among educators. Faculty development programs play a key role in enhancing teaching capabilities, promoting innovative approaches, and ultimately improving the quality of education. I am confident that this program will be valuable for all of us thanks to your active participation and cooperation. Let me express my special thanks to today's resource person, Dr. Bhaskar Babuji sir, for sharing his knowledge. Dr. Bhaskar Babuji sir is an experienced teacher who has inspired many students over the last 4 decades and has achieved significant accomplishments in both teaching and research. Finally, I want to say that the greatest strength of our department is our faculty members. I wish you all the best and thank you for being a part of this FDP. Thank you, sir. Sir, Karunakar sir. So can you hear my voice, sir?
Okay, sir. Please wait, sir. Thank you very much, sir, for your motivating speech and emphasizing the importance of faculty development program. Now, I humbly request our beloved principal, Dr. Sheikh Nazir Garu, to give his valuable message on this memorable occasion.
Thank you, sir. Sir, is my voice is audible?
Sir, very clear, sir. Very clear.
Okay. Respected head of the department and convener of 1 week international faculty development program, Dr. KVLN Acharya Garu, co-convener of this FDP program, Dr. T. Srinivasarao sir, senior faculty of the department, Professor P. Vijayasarathi Garu, staff coordinator, Mr. Karunakar Garu, and other senior faculty member, Mr. Muhammad Abdul Khadir, and other faculty members of Department of Mathematics, distinguished guests, esteemed speakers, research scholars, and dear participants from in and around higher education institutions. I request the participant, please mute your speaker. I request the participant please mute your.
అయ్యా వాట్సాప్ చేస్తారు అవేంటంటే మన పేరెంట్ వాళ్ళ పిల్లలు కూడా చదువుతూ ఉంటారు వాళ్ళ నెంబర్కి వస్తాయి ఆటోమేటిక్ వాళ్ళు చెప్తా ఉంటారు ఒక్కొక్కసారి అసలుకి వీళ్ళు ఎందుకు వస్తున్నారు చదువుకోవడానికి.
Thank you, sir. A very good afternoon, and it is indeed a privilege to inaugurate this International Faculty Development Program on Innovative Applications of Mathematics, organized by Department of Mathematics and in association with Institution Innovation Council. This workshop carries a special significance as it is dedicated to the memory of illustrious Dr. Komaravodu Chandrasekharan Garu, whose contribution to the field of mathematics remained unparalleled. It also pays a tribute to the Dr. Nagalla Prabhakar Rao Garu, the former head of the Department of Mathematics and a founder head of the Department of Computer Science Engineering at Bapatla Engineering College, whose vision and leadership continues to inspire us. I take this opportunity to appreciate the Department of Mathematics and the coordinators for their exemplary efforts in conceptualizing and organizing this intellectually enriching event. The theme of the Faculty Development Program, Innovative Applications of Mathematics, is highly pertinent, reflecting the evolving role of mathematics in addressing complex challenges across diverse fields. We are honored to have an extraordinary lineup of resource persons and speakers from prestigious institutions worldwide who will guide us through the latest advancements in this domain. Today, it is my pleasure to extend a warm welcome to Dr. J. Bhaskar Babuji, sir, a distinguished professor from the Department of Mathematics, Anna University. Sir is a highly regarded academician in the field of mathematics, known for his extensive contributions and expertise. We are deeply grateful for his presence and for accepting our invitation to lead today's session on graph techniques for cybersecurity. This topic underscores the intersection of mathematical theory and cutting-edge applications in cybersecurity, a field of critical importance in our digital age. Over the course of the week, this workshop will serve as a platform for learning, collaboration, and innovation. I urge all the participants to approach the session with the dedication, curiosity, and an eagerness to engage in meaningful discussions. Let us this faculty development program not only deepen your understanding of mathematics, but also ignite your passion for applying its principles to solve real-world problems. As we embark on this academic journey together, let us strive to uphold the legacy of excellence and innovation exemplified by the stalwarts we honor today. Once again, I extend my heartfelt congratulations to the organizers and my best wishes to all the participants. May this workshop be a resounding success and transformative experience for everyone involved. Thank you one and all. Thank you. Karnakar sir, it's over to you.
Okay, sir. Thank you, sir, for your inspiring speech. It is the time to know about today's resource person. Now I request one of our staff organizer, Ms. K. Sunita, to present the profound profile of Dr. J. Bhaskar Babuji Garu.
Good evening all. Welcome you all to a one-week International Faculty Development Program on Innovative Applications of Mathematics. I feel it proud to introduce today's resource person and dynamic researcher, Dr. J. Bhaskar Babuji Garu. Dr. J. Bhaskar Babuji Garu is a great senior professor working in the Department of Applied Sciences and Humanities in Anna University, MIT campus, Chennai. He did his BSc, MSc and MPhil in mathematics from Madras Christian College, Chennai during 1986 to 92. He got Cambridge University Scholarship, Aberdeen Scholarship, Defense Scholarship while doing MSc at Madras. He received joint CSIR, UGC, and JRF in the year 1992 in the area of mathematical sciences. He did his PhD in Jawaharlal Nehru Technological University, Hyderabad in the year 2004. He has published 158 research papers in various reputed international and national journals. Out of them, SCI 12, Scopus 45, UGC K 26, Web of Science 3, 14 students obtained PhD and 31 students obtained in MPhil under the guidance of Dr. Bhaskar Babuji Garu, and still guiding 4 students for PhD at present. He also guided and completed 66 MSc projects to his credit. He is a reviewer for Mathematical Reviews, American Mathematical Society, European Journal of Combinatorics, Southeast Asian Bulletin of Mathematics, and Allahabad Mathematical Society. He delivered 120 invited talks in various international conferences, seminars, and webinars. He got numerous memberships in scientific and professional societies. Presently, Dr. Bhaskar Babuji Garu is working in the areas chemical graph theory, graph labelings, number theory and cryptography, formal languages, and automata theory. Professor J. Bhaskar Babuji Garu is appreciated by one and all with his best way of teaching and remarkable research for the last 3 decades. His friendly nature, good attitude, gently behavior, research capabilities are additional qualities in him apart from his goodness and vast experience in the field of education and research.
Thank you, Sunita, for your nice introduction about Dr. J. Bhaskar Babuji, sir. I know that you are eagerly waiting for the lecture on graph techniques for cybersecurity. Hence, I hand over the session to Dr. J. Bhaskar Babuji, sir. Sir, please start the session, sir.
Thank you, Professor Karunakar. Can you hear me? Karunakar,
sir.
sir.
Yes, sir. It is
Hi,
audible,
hi,
sir.
sir.
Can you hear? I am audible.
Yes,
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 sir.
sir. Your voice is very
It
clear.
is audible, sir.
Okay,
It is
thank you,
audible,
one
sir.
and all. Thank you, one and all, Bapatla Education Society, to give a great, what do you say, introduction. I am feel proud. I feel always proud to be one among your society because I have been grown through Bapatla Engineering College. My short period from 1996, 99, and 2004, where I did my PhD under the supervision of our great professor, Dr. N. Prabhakar Rao. Of course, he'll be blessing us, he'll be showering us from up for the entire society, Department of Mathematics, for the family of Bapatla Education Society, Department of Mathematics, the entire Bapatla. All of us know very well that how our N.P. Rao, Prabhakar Rao sir, was dedicatedly serving our Bapatla Engineering College. He himself and along with his brother, Professor N. Sudhakar Rao, both of them developed Department of Mathematics and Computer Science, okay, to a greatest height. And all the senior professors who are now working in Department of Mathematics, including Acharya, my student, everybody knows how much effort N.P. Rao Gar has done and brought this institution. So I take this opportunity to thank all my colleagues who worked with me, who are presently working, who are working with me, okay, in Bapatla Engineering College before starting this program. So with the blessings of our both the professors Chandrasekhar Sir Rao and Prabhakar Rao, let me start my talk. Thank you.
Thank you, sir.
Thank you, sir.
Let me share the screen.
Yes, sir.
Beginning. Left it a little bit up. Can you see the screen, sir?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Sir, it is audible,
Okay, we
sir.
will
No
start.
problem, sir.
Okay, thank you, thank you. So let me congratulate the Department of Mathematics for this organizing this beautiful international faculty development program for 6 days. Hope this will be useful for all the people who have been watching this. Right, the today's topic, graph techniques for cybersecurity, as correctly mentioned by our principal of BEC. This is the current topic where people are more interested, right? So here we have a lot of things to be connected in this topic. Graph stands first, graph theory stands first here. What are the techniques we are going to use in graph that we'll be seeing slowly? And then let me give a brief introduction about the cyber system and cyber security. Okay, so one by one, let us go. Fine. How does mathematics help in development of technology? So just to start with, to bring to your mood, I just am putting the slides, few slides. Two things, that is the fundamental principles, that is called foundational principles and algorithms. These are the two things, right, which make development today's current. As you all know that computer science has gone into deeper and deeper, like AIDS, robotics, machine learning, deep learning. So earlier we had big data, then we had IoT, then slowly now we are in deep of deep learning and machine learning, and everywhere goes with the support of AIDS and so on, data and the artificial intelligence. Modern technologies are based on various foundational principles and algorithms derived from Max. Computer science uses various max logic and number theory to develop data structure and computer algorithms. So this one paragraph which I put before you tells you going to be the entire story of the day. So without mathematics, okay, we are not able to support the algorithms, and then only the algorithms are going to play the key role in cybersecurity. Over the last 2 decades, the institutions, education institution authorities in the country have been working hard to promote the use of information and communication technology. Earlier, we used to say ICT, information communication technology, okay, resource in classroom settings. Today, we shortly say IT. This move has been motivated by the need to improve the efficiency of teaching and learning, as well as need to ensure that students are properly prepared for interaction with the real world. When you start interact with the real world, your system becomes very, very powerful. What you study in the classroom has to be put practically. So whatever you try to implement your theory. So here, the modern technology is there, but how to implement, and so that we have to interact with the real world. Let us see the history of how ICT has evolved. So let us go back and see for a few minutes. Whether you know or you don't know, let us have a look on this data. 1837, the invention of Morse code and telegraph. 1876, we got the telephone for us usage. 1895, wireless telegraphy. And 1927, after a break in 20th century, for about 30 years break, we got 1927 television. So today where we are, we know it. So television 1927 has come, but most of the people in our country maybe they have saw television only 1997 or 1987. 1947 transistor, the most important organ. 1947 transistor came for the purpose of communication. The 1951, the UNIVAC 1, the first commercial computer was invented. 1969, foundation for internet. So this is the year which I was born. So, but when did I use my internet? When I was studying in Bapatla. When see my tongue has slipped. I'm telling I studied in Bapatla. Really, that is the truth. I studied in Bapatla, my PhD. So when I worked in Bapatla, I got my first what is a email ID. I remember Professor Sudagar, who was leading the computer science department. He helped me in opening an email account for me. Bhaskar Babuji at yahoo.com. So I cannot forget those things. So where is 1999, 1996, and where is 1969? So how back we are going? So today all the machine learning concept, which and the ADS, which are already came before 30 years in abroad. So we are going slowly, but we are very powerful. So our system has taken so much time to implement this into our education. Okay, let us keep that in one side. 1971, the first email. 1971, 1990, WWW, World Wide Web, 1990. And then 1991, the global system for mobile communication. 94, the World Wide Web browser has come. Then look at the twist then, Google 1998. So without this, we cannot survive today. Survival becomes very difficult because we have the entire world in our palm, in our mobile. So 1998, Google has come. So look at the advantage, the drastic advantage uh, in 100 years. And then see that 2001, the commercial 3G network and the beautiful, excellent concept, the Facebook in 2004. So today, all our students and even our childrens and kids and small children have Google, Facebook. They the iPhone in 2007, the latest one, and the Bitcoin in 2008. 2010 knocked out 4G, okay, with beautiful applications and speed. Of course, we are in 3G now, 5G now, 4G in 2010. But look at the break there, the development for 5G 2020 with a lot of obstacles and other things. The AI system defeating the world champion Go player at 2020 5G. So then we have a great tragedy. We had a great tragedy after 2020, the COVID-19 coronavirus, which has totally made us block inside our house. So that time, only these great networks have been helping for us. This ICT, the IT, that is, look at the usage of the 5G and other things, the Google and all the meetings. So up to 2023, okay, now recently you can think that still 350 million daily meetings are going in Zoom. Today we are in Teams. Now we are meeting all over the globe. We are united. So look at the development, how ICT started in the 18th, 19th century, and we are in the 21st century. So yet another 1.5 months is there to complete 2024. We always have to receive the history will be there for us ever. So that legal development now 2023 has come, 24 has come, and we're going to find 2025. But look at the great development, but how many obstacles would have been overcome? What is the obstacle here? The attacks. The attacks. The obstacle is the attack. So we have to survive with the equipments what we have, but we have to defeat the attacks. A lot of disturbance spoiling in between. Attacks in the sense not only terrorist attacks, attacking the cyber attacks. That's what I am going to talk about that. So today's talk is how to uh, monitor these cyber attacks, how to challengely work against these cyber attacks, how mathematics is going to be useful for this. All these details we see. So though we have a lot of communications here, confidential communications, threat is always there for attacking the cyber system. Okay. The information age has been dawned. We have increasingly relied on technology that we develop to support nearly every aspect of modern living. At this point in our history, we are dependent on complex computer system to manage and maintain the way our society and our world operates. Of course, computer manages transportation infrastructure, energy production, agriculture, political elections, military operations, financial markets, and many other critical processes. We all rely on it. It is imperative that we keep these systems safe from attack. That is the main idea. So cybersecurity is an exceedingly challenging problem for many reasons. First, the attack surface is vast. The attack surface is vast. The data is vast. It is just flying in the air. Anybody can take the data. Today, we are able to search through satellites. What are we doing? Where are we? And we cannot hide anything. Everything is being captured by satellite. So we have to safeguard certain things. The space is vast and increasing daily, resulting in it every changing threat landscape. For example, as we continue to write and produce software, yeah, we provide a steady stream of software vulnerabilities which can be exploited by adversaries. In 2020 alone, there are about 17,000 new vulnerabilities reported to the National Vulnerability Database. So additionally, we continue to expand the attack surface. We add devices to our networks, such as the infestants of Internet on Things devices, which provide advisories a multitude of typically low security entities, which can be used to perform cyber attacks, such as highly publicized recently the Maria botnet. So though we have a lot of security systems, still the threat is going on. How smart the teacher works, still the people, the notorious people will do copying in the exam hall. How tight security you make, still people are intelligent in breaking your tight security entering. For the national security, we have 3-stage security, 5-stage, 7-stage in airports, but still there is a threat for the or the higher peoples, okay, important peoples. So the security, though we make an intelligent move, the other side, the attackers also intelligently move and find a loophole. How safely you're closing the door, you're closing the cupboard, your bureau, your safety locker, and then your outside door, and then your grill door, and then you tell your security, I'm going outside for 1 week, and then you have a dogs in your flats and neighbors, everything's there. Still, the burglar comes and then attacks and takes. So, though you have tight security, you have passwords, you have wonderful passwords, user ID, strong passwords. Still, you have to go for OTP. OTP not for one single OTP. You have 2, 3 OTPs in various stages. So, even that, in spite of that, you have been cracked and then you have been taken away. So safety is most important. So intelligently we have to protect our data. Fine. This is here small this for information. So the web app, the database, internet facing applications, and then we have the directory services, file sharing here. So people are working here, employee workstations, and cloud services and so on. So threat attackers are there. The threat attackers are there. So there are the buffer overflow, SQL infections, and malwares executing via watering hole attack, lateral movement data, and so on. So this is the scheme where parallelly the attackers enter and then do their work. As the use of computer networks grows, cybersecurity is becoming increasingly important. To enable system administrators to better protect their networks, cybersecurity tools are developed to warn of suspicious network activity. In some situations, system administrators have to deal with millions of such things each day. Fine. So this is the real problem which we are having. So we'll go slowly to this after going through some basic concepts in mathematics, which is going to support our scheme. Fine. Cyberspace can be represented mathematically using a graph theoretic approach because of the basic structure of a graph is well situated by interconnecting world of computer networks. So when you say graph theoretical concepts, what is a graph? To simply say, most of the people will be knowing because nowadays the subject has become a main subject. Earlier it was elective paper in PG, and today it has become a compulsory paper in all the universities in graph theory. And for all the engineering students, people are aware of graph, especially computer science people. So graph has two components called vertices and edges, or we can say points and lines, or we can say nodes and edges. So these two components form a graph. Whenever there is a relation between two nodes, we join an edge between them. So that's all. Oh, so simple to understand a graph. I have 5 nodes. I can connect the 5 nodes A, B, C, D, E. If A is related to B, I put an edge between them. If C is related to D, I put a line between them or edges. So this way the connection has been done and a network is been drawn. So that network can be interpreted as a graph. Any network or circuit can be treated as a directed graph. So nodes can be associated with various types of hardware or virtual systems as well as routers and other internet infrastructures. Edges can represent the connections or the information flow between the nodes. So any information is passed is like an edge here, fine. Right. So with this opening, let me go for some basics and interesting things in number theory to make you come to the level of understanding what is the real work to be done today. So number theory as a fundamental body of knowledge has played a pivotal role to the development of mathematics. It provides a fertile ground of both professionals and amateurs. Many results can be stated in a simple and elegant terms, and the proofs sometimes are long and complicated. So this is the real beauty of the subject number theory. So the truth will always look simple. Only the liar will have to give a lot of designs and what is it, decorations to bluff. But when you speak truth, you can simply say the truth and go. So that this number theory, a very simple statements and looks very simple. The truth always looks simple, but the proving the statements are years together. A lot of pending is there. A lot of conjectures are there. Still, we are yet to prove a lot of results in number theory, though it is a very, very old subject. A very, very pure and the most old subject is analysis of number or the concept of number. That's called number theory. Even number theory, there are a lot of classifications of number theories there. Fine. So the proofs are very, very difficult in many concepts. Today, even you have the Goldbach's conjecture yet to be proved, more than 450 years old. Any composite numbers can be written as sum of two odd primes. So any composite number can be written as sum of two odd primes. It looks very simple statement, and you can prove it to for 2-digit, 3-digit, or 4-digit. But when the digits are becoming 10 power 9 and 10 power 10, very large numbers, then the problem starts because still we are yet to know how many. There are infinite prime numbers. Still, we are yet to know what is the largest prime. Today, one person will say, I have invented the largest prime. Next day, you will come and say, yeah, I have got the next largest prime. So still the days are going and it is an unsolved problem. So that's the German mathematician Kronecker wrote, God created the natural numbers and all else is the work of man. Beautiful statement. So only natural number is being given by God to us. So we people with the support, the intelligence, we developed other works. So here, cryptology consists of two parts. One is cryptography, another one is cryptanalysis. So the work cryptography is derived from the Greek word cryptosis, means hidden, graphene means to write. So cryptography is an art and science of concealing, meaning confidential communication. So how do you communicate confidentially so that others could not trap it, others could not come to know what is the secret? So this is like giving some information, okay, which is very confidential. I want to I want to communicate, okay, to a person such that others do not know. Maybe I can go and speak to his ears. It's private communication, but openly I can communicate certain things before the public. Before 100 people, I can communicate to my friend, but others don't understand. That is private communication. So that is called public. This is private means going and speaking to himself separately and telling communicate. It's private communication. Public means on public you speak, but confidentially you have to communicate the information. So how to do that is public communication. So I have here two type of system. One is private communication, that is called private, and another one is public. So two type of encryptions are there. So here cryptography means secret communication. Okay, let me take a good example, uh, make it very simple. Lock and key, lock and key. we want to purchase a lock. So we will go and purchase the lock. If you see, there are 3 keys, 5 keys, 4 keys, 6 keys, only 2 keys. That depends upon the company and the made. So we purchase the key and lock together. Who would have prepared the key for the lock? The person who prepared the lock would have prepared the key. So locking, opening the lock, unlocking. Locking, unlocking is done by the same key. You can't use a key for locking and you won't use another key for unlocking. Both are done by the same key. So the preparation of the key and the lock is done by the same person. So here lock and key are like your algorithms. Okay, you prepare the algorithm, you do the coding, you do the decoding, you do the encryption, you do the decryption. So like lock and key is cryptography and your analysis or encryption decryption. So let us see that cryptanalysis deals with breaking secret codes. So cryptography is secret writing, cryptanalysis is breaking secret message. Suppose I have the key with me, okay, fine, I can open it. Suppose I don't have the key with me, then what I have to do? I have to break it. But how to open the lock without breaking it? That means I should prepare the key in another way. That means I should study the lock, I should study the algorithm, I should study the problem, I should study how it is being encrypted. Then I have to break it. During World War II, 30,000 people were engaged in cryptographic works. 30,000 people were engaged in cryptographic works. The breaking of the Japanese Purple Mission code by US cryptanalysis shortly before the attack of Pearl Harbor led to the Allied victory in the Pacific. Today, the US government and business employs tens of thousands of people, spending billions of dollars annually on cryptology. So cryptology is consists of cryptography and cryptanalysis. Okay, so you want to do encryption, communicate, you want to do decryption, that is you want to break. The plain text is the original message that has to be transmitted in secret form. The cipher text is its secret version. So I want to communicate certain how the people are planning to write the objective questions. Okay, there will be some notorious people in the class who don't prepare properly. Okay, it's only objective. Come on, let us copy their plan and go. So you make it and give the question paper. Then he may have an action. Question number 1. Okay, scratch your head. It's A. Question number 2. If you scratch your ears, okay, it's B. Question number 3. Okay, if you scratch your nose, it is D. Or you just uh, scratch your face, it is C. So some code way of understanding communication tools. This is one type of verbal communication. And then you copy and you do malpractice in the hall. Okay, without knowing to the invigilator. But finally, the answer will be wrong because we are graph theorist people. We won't give the same question paper to all the people. We have A, B, C, D seating order. We have 4 type of question orders. And then A, B, C, D will be given. Then again, A, B, C, D will start. So in graph theory, there's a beautiful coloring concept that no two colors will be the neighbors. Such a way we can make a seating arrangement. No use of having this. These people thinking the same question order will be there, but the orders will be changed. So such a way that mathematics helps us even in all parts, starting from all malpractice can be managed using our algorithms. So here, that's an example, that's all. So the ciphertext is the secret version. The key is the explicit formulation of the cipher. So the job of the cryptanalyst is to discover the key and break the code. So this is a very difficult job, cryptanalysis job. So he will discover the key and break the code. Please open the lock. I lost the key. That means what you do, you want to break it. No, 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 it's very costly. I will not break the lock. I'll go bring some person, an expert who prepares key. So we go to a town and then bring an expert who prepares key lock. He will come and he will put inside all type of gimmicks, what and all key he has, and he will study by putting various key inside, sample key. He will study the movement inside with the sound and other things, and he'll try to prepare. He'll think, he'll have in mind how many left turn, how many right turn, ups and downs are there, which angle it is there. He may prepare, he may succeed. So that is script analysis. The process of converting plain text to ciphertext is called encrypting. So the device is called encryptor, that is a lock. The reverse process of intent recipient who knows the key is called the decrypting procedure. He is called the decryptor. So encryptor, decryptor, both are reverse process, lock and key. Both may be algorithm executed by people or computers. So we are the man, supercomputers. Our brain is supercomputer, more than supercomputer. Because what is a supercomputer? It's prepared by another man, not by another computer. A supercomputer is also prepared by man. So we are intelligent. The machine is not. The machine is smart and it is doing the duty. Why we are not appreciated? Because if we do our duty, we are more than the machine. Okay, why today lot of terrorism, illegal things, indisciplined things, okay, unwanted things are occurring around the society because the procedure is not tight, punishments are not given. So I'm not going away from mathematics. Mathematicians always get angry when students disturb the teacher in the class. It is not that the staff is getting angry because he is disturbing him. The student is disturbing a teacher when doing an integration problem, calculating the what is say answer. Okay, putting a diagram, explaining the graph and finding the region and solving the multiple integral. The students disturbs and the staff gets angry. Doesn't mean that he is getting angry, he is being disturbed. Not at all. A max teacher is always have the sense that he is very much angry on the student because he is disturbing his neighbor. You cannot disturb a teacher. We are paid for us. We are there for us. We can withstand any disturbance. But the problem is you are disturbing. The student is disturbing this neighboring student. He is disturbing another student who is paid the fees. So the greatest sin in the world is disturbing others. So I always say to students when I was teaching in Bapatla, when I was teaching in Tamil Nadu or teaching in Pondicherry, wherever I was teaching till today, I used to say that don't disturb others. So we are not here to disturb. The greatest sin in the world is disturbing others. If you don't disturb others, that itself a smooth life. So in that way, the teachers, max teachers are very sensitive because they are highly disciplined and highly motivated and they are logic people. Okay, the concepts in mathematics are logic like lock and key. So they always believe in having the truth speaking. So that's why I say that the things are going on because the algorithms are strong. The law is very strong, but implementation is weak. If you put the algorithm, the machine will not wait for you. The machine will keep on doing its duty. You cannot stop when the instruction is given. But the man is human being is not. We have lot of organization, we have sympathy, we have human values, and we have to think about all other things. So we are not in the position to implement the rule, the algorithm, the law very strictly. That's the reason why the entire world is having war. A lot of conflicts are going on. So I don't think that I'm going more out of the subject. Let me come back to our encryption decryption. So this encryption decryption are algorithms executed by people or computers. So they do their duty. Things are going smoothly. Crypto system is a system for encrypting plain text to ciphertext using a key. This is what the system requires. There are 5 types of crypto systems: affine, Hill, exponential, RSA, and NASCAP based on model arithmetic. The first 3 is conventional, that is private key. The last 2 is public key. Okay, so RSA is the most very difficult system. That's what the latest one, the RSA. Computer science people and all the people will be studying about the system. Okay, fine. So for this system, we require the prime numbers, largest prime. So how to prepare the largest prime? So if anybody asks you, have you seen the God? No. But suppose if you see the largest prime number, you can accept that, yes, I have seen the God. Because the largest prime you could not see. That it cannot imagine the largest prime because Euclid's theorem says prime numbers are infinite in number. So what is the largest prime? Okay, this is the largest prime. Then another fellow will come another 10 days and say, no, this is the largest prime. So the prime numbers, okay, still we are searching the prime number, the largest prime number. Can you find the largest prime number means you have found the God. So here we are going to look into the very, very basic, okay, that is scheme is here. I'm going to take a plain text and then play with you. I'm going to encrypt the plain text to ciphertext, okay, and then communicate. The other side, the key will be used by the decryptor and convert it as a plain text. Okay, in between the cryptanalysis will interfere. Okay, any signal is being sent from the army headquarters to the field. The attackers are ready to receive the communication. Either he will receive the communication or he'll disturb the communication. If he's not able to receive it and then go accordingly and attack us, he will may disturb it. Those days we had did not do this many satellites and other things. Today, if you put one rocket launching, the other rocket is opposing it and collapsing it. Those days we had only radar system, other system very limited by that. So when World War I and II, with that facility itself, they made a lot of damage to the society, to the entire world, the atmosphere. But today, a lot of facilities are there, so attacks will not be so easy. At the same time, can be protected. Only thing is, the thing is, the space is more, and then similarly we can identify easily. So here, the disturbance, okay, the smuggling or what you say, the cipher attack is very severe. Communications are being stealed every milliseconds from one person to another person. So attackers are always there to come in between. Cryptanalysis are there. Okay, in all crypto system, we are going to go for affine substitution ciphertext. So the very simple problem we are going to study. First one, I am going to take the most easy language is English because maybe I can ask a question to the people who are listening to my talk today. My first question to the audience is that do you accept the most easy language in the world is English? Anybody can interact from the participant side. I say a statement, the most easiest language to learn is English. Anybody can answer? Can you say yes or no? I don't think all are sleeping. Some people will be awakened. If you answer, so I get an boosted up. I get boosted up. So okay, people are following me. So anyone can answer. It's a small question. I don't expect right answers. I welcome wrong answers so that we can speak more. Meanwhile, add a sip of water. Yeah. Yes, dear participants of this workshop, let us interact for a minute. Here afterwards, there will be a lot of interactions. Get ready for it. There will be a lot of interactions. Professor Karnakar, just encourage your participants to answer my question.
Definitely, sir.
So it should not go one way, no. Once we start interacting, plenty of things I can tell.
Okay, sir.
Because the mathematics
Definitely.
is going to start now. Till now, I was talking something.
No. Participants.
Yeah, participants, you should come and participate. That's why
Sir,
you are
shall
called
we
participants.
Actually, we muted, sir. Actually, shall we unmute that?
Yeah, you can unmute. You can unmute. That's why I'm calling you for help.
Okay, definitely, sir. We will do it, sir. 1 minute, sir.
Yeah, please, so that they will be thinking now.
Okay, sir. 1 minute, sir.
Yeah, okay. So we should always be a quiz master in the class when we teach mathematics. Daily one quiz question we can ask and encourage our students. So
Okay,
that
sir.
way we can develop interest in teaching mathematics and listening mathematics in class. Every day you
Yes.
go with the maths quiz question, and at least you can give a Cadbury's 10 rupees chocolate to one student who answers properly.
It encourages, sir. Actually.
Sure, sir. Because that is way today we have to go with the students.
Dear
Yeah,
participants,
dear
actually we
participants.
unmuted the mic. Those who are
Yeah.
interested, you can ask the questions. Sorry, sir, so much interested to clarify our doubts. Dear
Yeah.
participants,
Yeah. Now,
those who are having any doubts.
yeah. So actually, I am going to start my concept now. At the end, I'll give you a lot of time for questioning. But now, in between, you have any questions, you write it in the paper and keep it from now onwards. But my first question now, whenever I ask, you can answer. I say English
sir.
is the most easy language in the world to learn. Why? Or yes or no? Maybe my question is very easy.
Sir,
If nobody is answering, then only TSR and Acharya.
Dear participants, you can unmute your mic and you can speak with Dr. Bhaskar Babji garu, please.
One of you can answer. I say English is the most easy language to learn. Do you accept it? I expect different answers. Ambrose, Dr. Ambrose, Savita Engineering College, Rajalakshmi Engineering College, Chennai. Professor Ambrose இருக்கீங்களா லைன்ல? Dr. Ambrose. No. Anybody can say hi, because I have put this screen. I am not looking to participants. I've made my full screen into this presentation, so I'm not able to read out the names. So voluntarily you can come. Maybe like this, I may ask you about 7-8 questions. I have very interesting questions to make you think. That's all. See, it is an FDP program, so definitely you should question. Not only at the end, if I give a chance, you can question in between. So I am giving an opportunity, free hand. Nobody is answering. Anybody can answer. Yes, sir.
Good afternoon, sir.
Yes, please. Good afternoon.
Sir, myself, Zuleha, sir.
Julega
From Crescent University, sir.
Very good. Julega, Crescent University, Abdul Rahman from Andalur,
Yeah,
Chennai.
Abdul Rahman. Yes,
Yeah,
sir. Yes,
please.
sir.
Answer my question whether you accept my statement that English is the easiest
Yes,
language
sir.
in the
I am
world.
accepting it because nowadays everyone is easily communicating only through English in most
Okay.
of the places. So I hope it is easy to learn.
No, you learn a language in your LKG, UKG, first standard. At that time,
Yeah, we took
only
that
you
as
know
a
the difficulty.
primary. Yeah, we took that as a first language. No, nowadays English as
Okay.
a first language in schooling.
Any other reason is there to my statement? Well, your mother tongue is easy, no? Then why do you say English?
But we not following mother tongue in schools, no, sir. In schools and
Why not
colleges.
in your house you are speaking mother tongue Tamil, no? What is your mother
From,
tongue, Tamil or Urdu?
Tamil, sir.
Tamil. Look, suppose now my workshop is in Andhra Pradesh. The base is
Okay.
from Andhra. So if I thought somebody will interfere and tell Telugu is the most easy language in the world, but nobody answered. Nobody supported Telugu. I have to support Telugu now.
Hello, sir.
Yes, sir. Please.
Hello,
Yeah.
am I audible?
As it is global language,
Yeah,
we are
audible.
giving importance.
Hello,
Yes, sir.
am I audible?
Yes, sir. Yeah.
Yeah, it's
Sir, Karunakaran
Go ahead.
please allow one by one, sir. Otherwise, it creates a disturbance.
Okay. No, I'll close it soon. One more person. Yes, one more person.
Am I audible?
Yes, you're audible.
Yeah, I accept your question.
Yes. Why?
But from temporary language.
What is that?
Karnakar sir,
accommodate.
Karnakar sir.
Okay, okay,
Please
fine.
allow our participant one by one, sir. Otherwise, we
Okay.
could not able to understand what is going on.
Okay, okay, Karnakar sir, you can mute now. You can mute. I'll answer. Karnakar, you can mute it. I can answer.
Okay, okay, sir.
Yeah. Yeah, you can mute everyone. I can answer now. Okay, Karnakar, shall I start?
Okay, you can start, sir.
Yeah. Now, no disturbance, right? I am clear now.
Yes, it is
Right.
also clear, sir.
Okay, now I'll behalf of Telugu, I'll also speak now. See, everybody thinks that mother tongue will be the most easy language, right? No, first of all, to learn a language, you require alphabets, right? You should learn the alphabets. The alphabets are less in number, language is easy to learn. In that way, if you see, English has only just 26 alphabets. Just 26 alphabets. So very quickly, LKG student is learning before going pre-KG itself is learning A to Z. Not A to Z, at least A to middle of the portion, A to J. Then after next 13. So here, number of alphabet is less easy to learn. Then only you can coin the word, then paragraph and speak logically. Grammar comes into picture. So to learn language, alphabets is must. So in that way, if you take the most easy language is English. The next most easy language in the world is Tamil. Now let us forget the world, go to only India. There are famous 20 languages, 24 languages are there in India. In that most easy, you will bring it English, easy. Then your next easy language is Tamil because there are only basically 18 plus 12 alphabets. But if you multiply mathematically, there are 247 alphabets. The 247 comes only by homomorphism, isomorphism concept like multiplication, adding, subtracting the 12 plus 18. That is 30 basic alphabets. So the next easy language is Tamil. The most difficult language is Telugu. Why? Because you have how many alphabets? How many alphabets are in Telugu? Sir, Karnakar sir, it is 56.
56, sir.
56. All other languages have less than 56. Kannada, Malayalam, Hindi, 53. All are less than. So that is the reason why all the Telugu, all the Tyagaraja Kirtanas are in Telugu. Define alphabet abstractly like mathematics. An alphabet is a pictorial representation of a sound. For all sound, you have a pictorial representation. That's only language. Telugu has all scripts for the sounds. In Tamil, it has its originality. It doesn't mix with the Telugu. So we have very less. So we have to require a teacher to pronounce the word sound. But Telugu, by learning the letters itself, he becomes clearly he can pronounce. So the most difficult is Telugu, the most easy is English. So now is the reason why we have taken giving the statement English. So let us communicate in English. There are 26 alphabets. I am going to modulo 26. What is modulo 5? Modulo 5 means 0, 1, 2, 3, 4. The remainders when you divide a number by 5 is the residues or remainders. Modulo class 5 has 5 numbers 0 to 4. 26 modulo has 0, 1, 2, 3 up to 25. So what I'm going to do is I'm going to give a number system, right? A to Z, 0 to 25. A means 0 ordinal number, B means 1, C means 2, D means 3, like that. Y is 24, Z is 25. So whenever I say 26, that goes to 0. When I say 27, it goes to 1. Whenever I say 28, it goes to 2. This is the process. So I'm going to communicate a word through this using this ordinal number, a ciphertext that is called affine ciphertext. The substitution cipher in around Caesar's cipher around 550 years before Christ, the Roman Emperor Julius Caesar, before 100 to 44 before Christ, sent an encoded message to his general Marcus during the Gallic Wars using the beautiful concept substitution cipher based on modular arithmetic. So now we are having modular arithmetic and congruence relations all in our number theory system in MSc. But those you think of before Christ, 100 years itself, they applied this modular arithmetic to do the encryption or coding, decoding business. So the Caesar cipher, small example I'm taking, shifting your letter to 3 places to the right. I can shift the letter to left. I can shift the letter to the right. I can shift 3 places, 4 places, 10 places, left or right, so that to jumble and confuse you. So I'm going to write A as D, B as E, C as F, D as G. So I'm moving 3 places to the right. So L is O, M is P, and then I have N is Q, X, Y, Z becomes ABC. This is a cycle, 3 places shifting. Okay, let me take the relation now. The relation is C is congruent to P plus 3 mod 26. P is the ordinal number, original value, and C is the ciphertext letter. That is what we are going to convert it for secret conversion. And then add it and do modulo 26. That's right, the remainder. This value of C and P should lie between 0 and 25. So P is the ordinal number of the plain letter and C is the corresponding ciphertext letter. So let us take a example, a message, have a nice day. This is the information I want to convey to you. Have a nice day. So let me write using Caesar key. I will replace each letter alphabet to ordinal number. H means 7th place. From the table, A is 0, B is 21, E is 4, A is 0, N is 13. So D, A, Y. So finally, Y is 24. So I have written all the ordinal numbers. Now I'll apply the Caesar transformation. C is congruent to P plus 3 mod 26. So 7 plus 3, 10. I'm putting here 3 plus 0, 21 plus 3, 24, 4 plus 3, 7. Likewise, 24 plus 3 is 27. I don't have 27. 27 is modulo 26 is 1. So here afterwards, I apply modulus. Whenever it crosses 26, it becomes a residue. So 24 plus 3 is 27. 27 is equal to 1 mod 26. Okay, this is my new, that is the Caesar transformation numbers. Let me go to the table again and find out what is the Caesar transfer text. That is, I put 5 letters in a block. Have a nice day has become KDYHD, QLFGH, 5 in a block, 5 in a block, DB. So totally there are 12 letters in my message. Have a nice day. 12 letters I made 5 plus 5 plus 2. So this is what I am going to convey to you. And then the person who receives the message, if he knows what has happened is shifted 3 place right, he will shift 3 place left and then he read the original message. So others will not understand. So what a easy problem it is. Okay, this is all this cryptography. That's all cryptography. No, this is only to make you interest in the subject, just to begin you what is happening. Okay, now let us see the depth in this. Fine. The person will receive the decryptor. He will knows the key. He will write the KDYHT QLFGHDB is the original number of the table, and then he knows what is the transformation. So he will write the inverse formula. The inverse formula is P equal to C minus 3 mod 26. Originally, the formula is C is equal to P plus 3. Now P equal to C minus 3 mod 26. And he will retrieve the number in the plain text. So now you go to your friend's house. What you do? You go to your friend's house. You have a kid there studying 5th standard or 6th standard. Okay, you want to pass the time with the kid. You just say, okay, let us play a game. You call the kid and then say, you know, addition, multiplication, subtraction. Yes, uncle, I know everything. Fine. You think a number 1 to 10 in your mind. I will find out what is that number. Okay, the kid will think the number. He will say you add 5 to it. Okay, then you multiply by 3. Then you say subtract 2. Then you add 10. Then multiply by 3 or 4. Then subtract 6. Okay, tell me what is the answer. The kid will reply to you very smartly. Immediately you will tell the answer. Yeah, the number which you thought in your mind is number 6. Oh, you get a applause, great applause. How, uncle, did you find this number 6 in your mind? So what you are doing here is you're doing the reverse process. Whenever you add, you subtract. Whenever you multiply, you divide. Whenever you divide, you add, you multiply. So you are doing the reverse process from bottom to top. It has been top to bottom. So whenever you put it inside, you have to take it back. So your fathers, forefather, they go to the field and then dig a well and then put it inside the precious gold and ornaments in a pot and then close it. After years, you dig it again. You dig it again in the field for water. You may get the precious treasure, and the government will come and take it go. So this is what happening throughout the world. So keep it inside, okay, take it outside. So that's the reason why in algebra, the concept of field is very, very important. So we have studied group, we have studied abelian group, then ring, then ideals, then come for integral domain, and then finally go for field and extension field and so on. So what is the beauty of the field with the two operations, multiplication and a dot? With multiplication addition, we have the properties of the concept. Finally, we say a commutative ring with the unit inverse exists, a multiplicative inverse exists. So here inverse should exist. Where it exists, it's the field inverse exists. So finally, for encryption integration, we go for prime numbers, we go for field, and then we use algebraic concept and dig out and take the inverse. So if inverse does not exist, then your system is waste. Whatever you put 10 rupees, should take back the 10 rupees. Morning, I give you 5 rupees. Evening, I take back the 5 rupees from your pocket. Then only the balance sheet will tally. Otherwise, there will be a credit in one side and debit on other side. Okay. So here, the concept is doing forward, locking, unlocking. So your earlier formula is C is equal to P plus 3. Now the formula is P equal to C minus 3. Okay. What a great beauty here. Look at this 10 minus 3 is 7. 3 minus 3 is 0. All are okay. Finally, 1 minus 3 is minus 2. 1 minus 3 is minus 2. But I don't have minus 2. I have to find the equivalent number minus 2. What is minus 2 modulo 26 is 24. If I ask now anybody, again the disturbance will start. So I could not interact because such a large number of people are participating. When I request the organizers to what I say, open out the mute, remove the mute, then the disturbance will come. So I had a lot of questions now to ask. Maybe you can, if anybody raise the hands, maybe you can unmute for them. Maybe I have the question. I have the question after 5 minutes. Okay, that's going to be a very nice question, right? So now I'm talking about the modulo 1. This is the minus 3 is minus 2. Minus 2 is nothing but 26 minus 2 is 24. I got the 24. So now I go back to my ordinal number and trace out the number. I get have a nice day. So I know the language. I split into have a nice day. So this is the information. Fine. Yeah. Now the question comes for you. Let us understand. Please listen carefully. Sir, can I make this system little bit hard? Can I make the system little bit hard? Do you say that you cannot break? Can you say that you cannot break? No, who said you cannot break? Any system can be break. Look at this. Look at this. After all, you can add the number C is congruent to P plus K. It is K from 0 to 25. Trial and error method. Trial and error method. I try for K equal to 1, 2, 3, 4. At one stage, I get the answer. I can write an algorithm, try in several ways and take out, trace it out. What is the secret K? So nothing is difficult in the world, but I have to make it tough. That's why they're asking you a strong password. Give a strong password. You give a number. Your password is in 8-digit. Okay. Capital letter, small case, lower case, special symbol, numbers, digits. Okay. So all mixed together, you make your most of the people will have a date of birth or hometown or lover's name or wife name or son's name, daughter's name, and slowly everything will last. So think intelligently that others could not identify. Make your password very strong, your user ID very strong. Okay. Now if you go to with all these great things, you go to the PIN number to your what is your ATM machine and then take. Still somebody will come on trace out and take. So that's why OTP is asked. So if you put more than 10,000 your ATM machine, immediately OTP will come to your mobile. Then you should put your wear your specs, take your mobile and see the OTP. This time, before I do all this nonsense, the time will elapse. The machine will say that your time elapsed, you go buy, get buy. That's all. I cannot take my 12,000 rupees. So what I do very cleverly, I take 9,000. Every time I take 9,000. 4 times I take 9,000, 9,000, 9,000. 4 nines, 36,000 I will take from ATM. Meanwhile, the big crowd will be standing behind me and be shouting, "The old fellow, what are you doing inside? Come outside, it's very phone." So this is the today's world. The OTP is helping us in that way. So every stage by stage to payment to withdraw or transaction. Everywhere this OTP is one-time password is useful. So here tracking is not so difficult. See, people, 4 or 5 people do ragging. What happens? Okay, investigation starts. Oh, these fellows are doing ragging. Okay, complaint on you. Oh, come on, 5 people. HOD principal will be there, and then you will be called inside. You will be asked very humbly. Then you will say, no, sir, I am a very good family. I am coming from a good society. I am a very nice fellow. I am so and so great. I won't do ragging. I hate ragging. What nonsense complaint it is? You will say, you go. Next fellow will come. You ask, did you do ragging? No, sir. I'm very innocent, sir. I don't know how to do ragging. What is ragging? Okay, you can go. Next fellow will come. Oh, hey, did you rag? No, sir. I was not there at the time, sir. So, sir, no, sir. I am very nice person. My father is great. My mother is great. My grandfather is great. I am, you know who I am. I'm son of this great fellow politician. I don't do ragging. I know the rules. All the 5 fellows will go. 2 days you leave them very freely. Investigation starts the third day. You offer a coffee in the principal office. One by one will be called. One will enter the door and he'll be allowed to the next door. He'll go outside. Like that, 5 fellows will be called one by one. One by fellow will come and he'll go outside. Second fellow will be called. Okay, yes, sir. The previous fellow told all the truth. You are being caught now. Whether you accept or you get punishment. This fellow will take a white paper, write and give everything. That what happened, what and all happened, he will again go. Third fellow will be called. He will say the first 2 fellows already told the truth. If you don't tell the truth, you will be penalized. Your certificate will be taken. You will be imprisoned. The third fellow will take a white paper. He will write big story what and all happened. He will write about all other 5 people and give. So likewise, investigation, interrogation will go. Everything can be found out. So interrogation is always possible. So this, after all, 26 possibilities. Can't you give the numbers and trace out? Yes, easily we can do. So look at this. So then there comes the cracking the code. So universally available knowledge of relatively frequency distribution of letters. Okay, now my question is, which is the most frequently used alphabet in English? Which is the most frequently used alphabet in English speaking writing? Anybody can answer? You have answer most frequently used English alphabet.
Q.
Anybody can
It's
say?
E.
Very good. E. Who are you? Can you answer? Who can you? Can I know your name?
Rani, sir.
Yes.
I'm Rani from Telangana, sir.
Your name, please. I could not hear.
Rudra, Rudra.
Okay, Rudra from Telangana. All the best. Very good. I appreciate you. E is the correct answer. E is the most frequently used alphabet in English. So that is a catch. Frequently, you will be using E. So look at the statement here. A ciphertext has been given. A very lengthy ciphertext has been given. We have to find out what is this. We have to decrypt it. We have to decode it now. So what is the frequency table? I can draw a frequency table for this given statement. So how many times A is occurring? How many times B is occurring? How many times E, F, G up to Z? So here Z occurs 2 times, K does not occur 0, A occurs 9 times. Most occurring high frequency is 12. So L occurs 12 times. So L is most occurrences. So I can guess that this L should be our E. The L should be our E. What is the position of L? What is the position of E in the ordinal number system? If we check that the position of L and E, the position of L is 11 and the position of E is 4 in your system 0 to 25. So I can put it in the scheme that is C is congruent to P plus K. That is nothing but 11 is equal to 4 plus K and find out K value is 7. So I can now operate C is equal to P plus 7 mod 26. I can retrieve the original track, the message P is congruent to C minus mod 7, C minus 7 mod 26 and apply this for the numbers and then get back the information when the ordinal number and the information is very nice. Let us never negotiate out of fear, but let us never fear to negotiate it. This is the passage from the President Kennedy's inaugural address. Now, this has been taken from the book called Introduction to Number Theory by Thomas Cauchy. Thomas Cauchy. Okay, so beautiful line by President Kennedy. You might have a question, sir, why you are taking such a long statement? Then only more ease will come, right? That's why I took. So I want to teach you, so I have taken this example. So now the question is, right, sir, what is this very simple cracking is also done? Then what is use of this system, ciphertext, this cipher? Can you make it tough? So more and more confusion, then you have to confuse the people, jumble the sentence. Why do you shift right side, shift left side? That can is also easy, shifting right or left, one and the same. Now my question is, y equal to mx plus c. Y equal to mx plus c. What is the value of x? Y equal to mx plus c is a straight line. M is the slope, c is the y-intercept. If I take a straight line y equal to mx plus c, I have infinite points. Of course, okay, fine. To draw a line, I require 2 points. I have drawn a line. Infinite points are there. So my question is now, what is the value of x? Y equal to mx plus c. What is the value of x? I will answer x is equal to y minus c divided by m. X is equal to y minus c divided by m. Hope you can understand. Y equal to mx plus c. You can write in a piece of paper. So x is equal to y minus c by m. Well, so y minus c is an integer number. Divided by m means what will happen? The system may collapse. You may not get an integer. So can I say y minus c by m, or I can say 1 by m into y minus c? 1 by m into y minus c. What is 1 by m? 1 by m is multiplicative inverse of m. Now I have to say additive inverse, multiplicative inverse. What is inverse of additive inverse of 5? Minus 5. What is additive inverse of a? Minus a. What is additive inverse of 2? Minus 2. What is additive inverse of minus 7 plus 7? What is multiplicative inverse of 5? 1 by 5. It is not an integer, it's a real number. What is the multiplication of 10? 1 by 10. So the problem starts now. I want the inverse as an integer. I don't want my inverse to be a real number because I am dealing with the number 0 to 25. I am very poor fellow, only 0 to 25 I am having hand. In this only I have to play. So how to find the inverse of m? In your field of modulo arithmetic 26. Look at the statement very carefully. Where is your field? My field is very powerful field, agricultural field with the Krishna or Godavari water where I plant, I do my fertile agriculture. That is my field in reality. Where is my field? Field of integers, field of real number, field of rational number, field of complex number, modulo class 26. In this only I have to find the inverse of m. Okay, what is mean by inverse? Multiplicative inverse. An inverse of A is said to be B if AB equal to the identity 1. AB equal to 1. If AB equal to 1, I say A is multiplicative inverse of B and B is multiplicative inverse of vice versa. Hope you agree now because we are all close with algebra. A is inverse of B means AB equal to E, identity 1. Now my question starts. Can I make this very difficult? Like instead of putting P plus K, I can put C is equal to something like AP plus K. C is equal to AP plus K. So that P is C minus K by A. So I multiply P by A, magnify it. I do translation by adding plus K. So AP plus K is a big number. Out of mod 26, I get some other number. Then find the inverse. Find the inverse is C minus K by A. That is my P. That is my P. So now some type of interest has come now. So what is inverse of A? There is a question whether inverse exists. That is another question. Now the question for the audience. Suppose I have C is equal to 3P plus K. Suppose I have C is equal to 3P plus K. A equal to 3. Suppose I have A equal to 3. What is A inverse? Question for the audience. What is inverse of A in modulo 26? Inverse of 3, A equal to 3. What is inverse? Inverse means when I multiply by another A and B, if A should be equal to 1.
29. Is it 29, sir?
How do you say 29, sir? 29 is not a number for me. I have number only up to 0 to 25.
19.
9, sir.
How do you say 19? How do you say 19?
19.
Then it will be
9,
3,
sir.
sir. 3.
No, somebody
Nine.
said
Then it
9.
will be 3,
Somebody
sir.
said 9.
Sir, 9. Is it 9?
No, one lady's voice I got 9 answer. Who's that?
Yeah, 9. 9, sir.
Before you, one madam also told 9.
Okay, sir.
27 modulo 26 is 1.
9 into 3 is 27 and 27 is 1 modulo 26.
Very good, both of you.
Yeah,
Very
it's
good.
9.
Yeah, three tables. If we go spell the 3 tables, 3 9s are 27. 27 modulo is 1. Yeah, very good. So the inverse of 3 is 9. The inverse of 9 is 3, vice versa. Now again, it's very interesting. Inverse does not exist for all the numbers in the modulo 26. So if A inverse exists means the GCD of A and 26 should be 1. The greatest common divisor of A and 26 should be equal to 1. If this is the case, inverse exists. So you have to choose your A such a way that GCD of A and 26 should be equal to 1. So these are the certain techniques. So now elliptic curve cryptography has come. You have elliptic curves, you can design. See, I want to find the inverse, unique inverse. If I have a linear equation y is equal to mx plus c, then you say y minus c by m, fine, good. If I say quadratic ax squared plus bx plus c, you have 2 roots. Which root you will take? That is the question. You have a cubic equation, you have 3 roots. You have a n-dimensional nth degree equation, n roots. So I want a unique solution. I want a unique inverse. The inverse should be unique. So that's why the subject becomes interesting. So there are a lot of procedures, there are a lot of ways in which you can hide the information through matrix transformation, to elliptic cryptography, through automata. Okay, the triple system of equations like this text, hill chippers, hypertext, lot of ways are there hiding. See, I will hide, I will give a chance, right? Lock the key and then give it to my friend who is in my next street, means that is a private key. Whenever I go and come back after 10 days, I get the key from his own. But simply I say, I will lock my house, throw the key in my garden. I lock the department, my room, and throw it in BEC, Bapatla Engineering College campus garden. Challenge you people, search it and get it. We cannot take it. I challenge. That is a public key. Public key. Simply I lock the key and then throw it in Bay of Bengal. That is not public key. So it should be possible, but not so easy. So it take time, years together for finding the key, searching the key. The field is open, but still you are not able to find the data. It's very, very difficult to find out the key. Such a way, if you tighten it, if your encryption is such a way that for encryption is very, very difficult, then your encryption is valid. It is a beautiful algorithm. It's a very good algorithm, right? So constructing a difficult key is the main theme. So for that, the attackers will get failure. You'll get fed up. The attackers will get fed up. They could not they could break your code, and the attackers have become failure. So they get misleaded also. The attackers you should confuse the attackers such that your communication system is maybe simple, but you complicate inside the system. Okay. Nowadays, what the administrators are doing, what is the use of studies? What is the use of education? Make things simple. There was one beautiful statement on one research paper, which I want to share with all your people. When I was doing my research in Bapatla Engineering College, under supervision of Prabhakar Rao, I used to come to Institute of Mathematical Science, Tharamani, Chennai. and take the papers. And one paper I saw which made me to bring this PhD. One paper in Unitas Mathematica journal, just 1.5 page paper. 1.5 page paper, research paper gave me one conjecture. All trees are magic. That's all. The simple line that made me a PhD. So that time I was searching lot of literatures. One paper written by Bill Bithell, one researcher from South Korea, Bill Bithell. He has given a beautiful statement. I'll just tell the statement correctly, slowly. You just have it in your mind. It is very easy to confuse things, but it is very, very difficult to make things simple. It is very easy to complicate things, but it's very, very difficult to make simplify. That's what today all administrators are doing, all education people are doing. I'm highly educated. What is use of highly educated? You make the thing simple. Those days, getting a ration card, opening an account, getting a admission, applying for an engineering college, medical college, okay, purchasing a land. So whatever may be system, I want to apply. I want to apply for a OBC certificate. I want to apply for a date of birth, death certificate. Everything may complicate. Getting admission, filling up a form gets complicated. Now we think all simplified in easy way. The mobile itself you're doing. Not only that, there you should not complicate. The application should not be complicated. It should be very simple. Asking simple questions. Get the full data. One thing is Aadhaar number itself today, PAN number, Aadhaar number, everything will be ruled out. Your account will be open empty. That's all. So simply tracking and then cracking. That's all. So my thing is the educated people should try to simplify the system. Educated people should not complicate the system. That's why I learned through that research paper, the wordings, and then I started my research. So I did from easy to difficult. So today I teach my students also in the classroom, make it from simple to difficult. Go steadily. Okay, they apply this, interpret this, try to understand the problem. So here the thing is, the scheme is like this, how to complicate this, but the original thing is been preserved. So to complicate, we should confuse. At the same time, logically, the scheme should be, the inverse should exist every time, inverse process. Okay, so with that, I just go to the next phase of my talk, that is encrypting dictating number using labeled graphs. Now I'm going to take my platform as labeled graphs. Okay, so here my my scheme is, I'm going to take the original message, and then I'm going to, my original message is a number. For example, a PIN number or a user ID, something, a number, any digit number, whatever it is. I want to communicate this number. Okay. And I will communicate this number in a complete graph. I'll communicate this number in a complete graph KN. Okay. And then I'll encrypt it using a scheme. And then I will hide my key in one triangle. That triangle is called cycle C3. 3 vertices, 3 edges, cycle C3. Then the person will decrypt the other side if he knows the formula. Otherwise, it's a public. He has to find out what is this hidden thing inside. He has to find out the key, that cycle C3, and then use the key properly to decrypt it. So this is my block diagram proposed system. Here I am going to work out here with the modulo class Z3. What is modulo class Z3? The three numbers 0, 1, 2. I'm going to label the vertices and edges. I'm going to labeling means naming the vertices, naming the edges. See, I have a name called Bhaskar Babuji. Okay, everywhere I've been called Bhaskar Babuji. Maybe I may have some other name in my house. My parents may call me in one name. My wife may call me in one name. My children may call me in one name. And finally, with the office, college, they may call. So I can have any number of names. So here I am playing with the two names. That's a twin labeling. For a vertex, I'm having an ordered per alpha I. For a wedge, I'm having an ordered per beta comma gamma. For my convenience and for calculation purpose, I'm going to add. Now again, I'm going to start the question time. So two questions I'm going to ask. People interested, can you raise your hands and then get muted? Okay, you know what is a complete graph? Can you define a complete graph? Just like we can have a fun, that's all. Complete graph.
Sir, a graph in which each vertex is adjacent to every other vertex.
Okay, this is one way of telling. Correct. Each vertex is adjacent to every other vertex. Still reformed. Even find this correct. The answer is correct. Yeah. Any other way of telling?
Excuse me, sir. Sir, a graph is
Sir.
created if each vertex connected to other vertex. Say, for example, K to 3.
Okay, no, fine.
A graph is said to be sir, may I say?
All the answers are correct. Your idea is correct. You know the answer. So I'll put it in this way. But every yes, please.
Sir, may I say? Hello. Hello.
Yeah. Karnakar sir.
Sir.
Yeah, I should close it by 5 o'clock, right?
Okay, sir.
What is the time now?
It is a 4:40, sir.
So I have to quickly I'll do it, sir.
Okay.
Fine.
Sir.
So I'll tell the answer. All of you are correct. Answer is correct. Maybe I'll put like this. Every pair of vertices are connected by an edge in a graph. A simple graph in which every pair of vertices is connected by an edge. Okay, now my question is how many edges are there in a complete graph Kn? How many edges are? Yes?
N into n minus 1 by 2. N minus 1. N into n minus 1 by 2.
N into n minus 1 by 2. Can I say NC2?
Exactly.
Yes, good. How many triangles are there in a complete graph? How many triangles are there in a complete graph? Very good. NC3. You are right. NC3. 3 vertices combined together a triangle. 2 vertices combined to give a edge. Very good. NC2 vertices edges. NC3 triangle. So in a complete graph K9, I'm going to take the K9 graph, and in that K9 graph, I have 9C2, 36 edges. So totally, I'm going to use 9 numbers for 9 vertices. Number 10, 11, 12 up to 45. So number 1 to 9 for vertices. Number 10 to 45, that is 36 edges. Totally, I'm going to employ number 1 to 45 in a complete graph K9. There will be 9C2, 36 edges. And how many triangles will be there? 9C3 triangles will be there. That's 84. 84 triangles are there. In that one triangle, I'm going to take and hide by key. That is a scheme. Okay. So look at this. I'm going to take a number 363, small number for our understanding, which is divisible by 3. Any number, if I give, you can check whether it is odd number or even number. Divisible by 5 or not divisible by 5. Divisible by 10 or not divisible by 10. So I am interested here modulo 3. So I want to divide by 3 or not divide by 3. This number is divisible by 3. I have a scheme now. If it's not divisible by 3, I'll go for the other method. This algorithm is for divisible by 3. I'll take my magic constant to be 30. My key value to be 30. This option I am doing by myself. You can do your own option. I split the vertices set into 3 groups V1, V2, V3. That is V1, V4, V7, V2, V5, V8, V3, V6, V9. And my edge set is 36 edges in this order. So this is what I do. So I will give the label for the vertices 1 to 9 for I running from 1 to 9. The second component and the first component is the residues 0, 1, 2. Repeatedly for the 9 vertices. For the edges, I give the label as pairs like beta, comma, gamma. Okay. So I will hide my key inside one cycle, one triangle C3, that is V4, V6, V8. So the label of the vertices are V4, V8, V6 will be 4, 8, 6. That's the second component 4, 8, 6. The first component will be 0, 1, 2 in order. So that will be coming repeatedly many times. So I am taking the number 363 and splitting the number into 3 parts. You can do by yourself and see how I can do this is If I split into three parts, for example, 102, 178, and 83, one number is divisible by 3. That means the residue is 0. For example, I name it as N0. 102 divided by 3, residue is 0. Next number, if I divide by 2, the residue is 1. I name it as N1. The last balance will be a number. Definitely, it is giving the residue 2. I divide by 3. 83 gives me 2. Randomly, I took three numbers. You can take in your own style. You can take 75, 120, and balance. Definitely, you'll get the answer. One will be N0, the residue 0. Another one will be N1, residue 1. Another will be N2, the residue 2. So N0, N1, N2. So this can be done for any number which is divisible by 3. So I have framed the triangle V4, V8, the edge V8, V6, and V6, V4. What I'm going to do is I'm going to put these numbers. Look at the diagram very carefully. There are 9 vertices. The vertices are 1, 2, 3, 4, 5, 6, 7, 8, 9. Second component is named as 1 to 9 running number. The first component of the vertices are given 0, 1, 2, 0, 1, 2, 0, 1, 2. Just to confuse the person who looks the label, he gets confused. So 0, 1, 2 is repeated. So this is the for vertices, 9 vertices. I have marked red color for our understanding the triangle, that is a cycle C3, okay, which is where the key is hiding. Why do I say this as a key? What I'm doing is, look at this vertex V8, this is V4. Add 4 plus 8, 12. 30 minus 12 is 18. So here 30 minus 4 plus 8 is 18. Next, this edge 30 minus 8 plus 6 is 16. 30 minus 6 plus 4 is 20. So I label this 18, 16, and 20 or the second component for the edges. So how do I get this 18, 16, 20 from the magic key, from the magic constant 30? I subtract these edge vertex values and put for the edges. So the vertices of this edge carries 8 and 4. The edge carries 18. So add this 8 plus 18 plus 4, you will get 30. 4 plus 20 plus 6, 30. 6 plus 16 plus 8, 30. So all the three sides of the triangles are getting the same constant. It is called magic concept. If all the three sides of the triangle get a distinct constant, it's called anti-magic. In graph labeling, we have application of magic, anti-magic labeling. This is that one application which we have done in 2012 with my team in Anna University. So three distinct constant, if you get, it's anti-magic, or n distinct constant you get for edges, you get anti-magic. All the edges have same constant, you get magic. Here, this triangle, among the 83 triangles or 84 triangles in this K9, only this one triangle, all the three sides are having the same constant. Not only that, if you look at the orientation is given like this. The arrow goes unicyclic. It goes unicyclic. Whereas for a number which is not divisible by 3, it won't be unicyclic, it will be opposing. Now, this is the scheme for the second component, 18, 16, 20. What about this 59, 27, 34? How do you get 59, 27, 34? You know the N0, N1, N2. I divide by 3. I put the floor value. The floor value of N0 by 2. That is truncate the decimal part. Divisible, divide by 3, 178. Answer quotient is 59. 83 by 3 quotient is 29. 102 by 3 quotient is 34. So this is the values of the edges in pair, that is beta gamma gamma for this particular graph K9. In general, if I generalize, if I take a vertex PQR, then K is key minus P plus Q, K minus Q plus R, K minus R plus P. This is N0, N1, N2 by 3. Floor values will be for any general graph of K9, complete graph. So now in this way I do it, and for all other edges, I remove the red color while communicating. Only for our reference, I have red color. Now, how many numbers are being used? 1 to 9 is used out of 45. 16, 18, 20 is used. What are the balanced numbers? 10, 11, 12, 13, 14, 15, 17, 19, 21 to 45. So those numbers I give for other edges, but I repeatedly use 59, 27, 34 to confuse the people who look at the structure of the graph. 0, 1, 2 is used, residues repeatedly. 59, 27, 34 will be used repeatedly. So that this is the scheme here. I will write out in general, remove all those numbers which is used, unused number. I also put orientation for this direction. I get the graph like this. This graph will definitely confuse the people. It has orientation, and there are 84 triangles, and then 34, 27, 59 is repeated, 0, 1 is repeated. Only thing is he has to find out, identify the decryptor to identify the red color triangle. Will he identify the reticular triangle? If he has the knowledge, he will identify the reticular triangle. Magic concept, anti-magic concept in graph labeling is the main application of this particular case. So the decryptor will receive the graph. He will try to write in a modulus, a matrix, a symmetric matrix, the values carried out, and he will do the operation. This is one scheme of doing. But let me find out for the diagram. If you look at the diagram, this is the triangle red color. So I will do the decryption using this formula. This formula is constructed very simply. That is, what we do is 34 into 3 plus 34 into 3 plus 0. 59 into 3 plus 1 because the arrow goes towards 1. 27 into 3 plus 2. So that's where I get the number 363. The arrows are unicyclic. If the arrows are opposing, it will get the other number. Here it is towards 0, add 0, towards 1, add 1, towards 1. That's the remainder, and this is the quotient. I get the number 363. Suppose the number is not divisible by 3. I will not get n0, n1, n2 as 0, 1, 2 residue. I will get repeated residue. Either 0 will repeat. This is a sample 102, 178, 87. You can write your own way of writing. Definitely, you will get either 2, 0 or 2, 1 or 2, 2 balance. 2 is missing here. Sometimes 1 may be missing. Sometimes 2 may be missing. So it will not be distinct residues when you take a number not divisible by 3. This is the rule in number theory. Okay. So with that, I draw the graph. I do the application, same procedure. And here the orientation is different. The orientation seems to be different. Look at this orientation. This is 59 into 3 plus 1 and 34 into 3 plus 0, but 29 into 3 plus not 2 plus 0. It's opposite direction. So I get 367. So this way I can encrypt, decrypt through graphs. So how to choose this 30? That is again the procedure is there, algorithm is there, how to start of 30. Okay. So this is one scheme in 2012, and another one type of communication using the Gödel number coding that I did when I was working there. I started and then I completed while coming here after Bapatla. The one-to-one correspondence between elements in arithmetic system using fundamental theorem of arithmetic. Any composite number terms, product of powers of primes. So this is Gödel number coding system. I can communicate a number by splitting into canonical decomposition. For example, 72,600 can be written as product of powers of primes. Whenever a prime is missing, I put power 0. So only the sequence 3, 1, 2, 0, 2 will be communicated. Gödel number of communication system. This is available in Kenneth Roshan book. You can see discrete mathematics by Kenneth Roshan. You have Gödel number coding system. This was once upon a time Gödel communication system. Write the powers of the primes alone. Then the decryptor will take it back. So I use this idea in a graph using fundamental theorem of arithmetic. Write a number with the help of a graph by yodeling only the prime numbers, prime components which are used in the number. 360 is 2 power 3, 3 power 1, 5 power. This is the label of the edges. 5 power 1, 2 power 1 plus 2, and 2 power 3. So with the help of the edge vertex count, the label of the edges incident on a vertex, I count it and then I put the raised to the power. So I take it back by the same way. So here we were successfully writing algorithm, and this paper got published. Earlier in 2005, it is very old work. So even if a very large number like 4,32,000, I can split using fundamental theorem of algebra 2 power 7, 3 power 4, 5 power 3. I use only 3 prime numbers. The 3 prime numbers 2, 3, 5. But there was a deficiency. So I took a number which is neither prime nor odd, and then raised 2 power 3 plus 2 power 3 plus 2 plus 2, 3 power 3 plus 1, 5 power 1 plus 2, 1 power 2. So this gives me the answer, that is 4,32,000. So this is one way of coding system. Plenty of encryption, decryption of numbers through graphs, through programs by DNA. Recently, we are working out with my research scholar. By DNA sequence, we are able to do encryption, decryption. Very soon, we will be publishing those work also in future. So that is more. But any system can be breaked, but which is not possible to break right is RSA system is very powerful. Now look at the attacks, cyber attacks. We come to the climax stage. World Wide Web can be modeled as a directed graph where each web page is represented as vertex, and where an edge starts web page A and enters the web page B. If there is a link between the points A to B, because new web pages are created, others are removed somewhere of web. Almost every second you are adding and deleting, and the data has been recovered. So look at this. These are certain basic local area networks, LAN systems, star, very old. I'm talking about this ring, hybrid of ring and star is a LAN, which is a wheel graph. All these things are highly useful for communication system. Okay, so call graphs can be used to model telephone calls in made network, long distance telephone networks. In particular, directed multigraph can be used to model calls. So I can edge representation of calls of telephone numbers, okay, from which the call was made, and the end of the telephone number to which the call was be made. We need to direct edge because of direction graphs. So finally, how the multiple edges are used in how many calls are going from one number to another number. This can be modeled graph. Then your IPv6 multicasting scheme came, and then this was also interpreted, and problems are sorted out from this using graph theory. And the final thing is take a graph, the IP network, and draw a graph and then make this spanning graph. What's a spanning subgraph? A spanning graph have same number of vertices. Edges will be less, so that all the can make a tour to all the vertices. Okay, so then from the spanning graph, we talked about vertex covering, like you're coloring vertex covering, and the concept of domination took place here. By vertex covering, we can protect one vertex with the help of other vertices. You can take the vertices of the neighbors. Okay, that will be the degree of the vertex is k. K vertices will be secured by one person. So I can think of the domination set of a graph of a network, and then I can secure from the virus attacks by the first neighbor. Similarly, I can expand to the second neighbor and so on. So simulation was carried out in large internet like uh, virtual networks showed the topological routing has big impact of worm propagation. The importance of finding the worm propagation is to hinder them in real time. The main idea here is to find minimum vertex covering of the graph, whose vertices are routing servers for each edge and connection between these particular routers. Then the optimal solution is to find the worm propagation, the network defense strategy. In a graph, the set of edges is called edge covering of G. If vertex in G is incident on an edge, on one edge in G, the set of edge that covers the graph in G said to be edge cover. Okay, and or a covering subgraph or simply covering of G. So this concept was again used for say the network. At the last, we can say that how we have a lot of research paper available in website for cyber attacks and graph networks. Application of graph networks in cyber attacks. These are the keywords I give it to you. You go and study in the what is a uh, uh, Google. You just search with the keywords and find out. You have plenty of applications, right? Thank you very much for patient hearing. I hope I have made some interest in you to make you study further. Thank you, Anurag. Thank you very much.
Bhaskar Babu, sir.
Yeah, I stopped. Yeah, I stopped. Yeah.
Sir, Bhaskar Babu, sir.
Sir?
Video.
Yes, sir. Yes, sir.
Bhaskar Babu, sir. Thank you very much, sir.
Thank you.
So for your insightful and valuable lecture. Your lecture was not only informative, sir, but also more useful to us. We truly appreciate the time and effort you put into preparing and delivering such a comprehensive and thought-provoking section. Thank you, sir.
Thank you. Any questions? Maybe you can ask.
Sir. Karnataka, sir.
1 minute, sir.
Yeah.
Respected Babuji, sir, I have given a wonderful lecture on graph techniques for cybersecurity, which enables us for predicting outcomes properly. This is the time for question and answer session. Those who are having doubts, please ask the questions and the sir will clarify your doubts. All of you please ask one by one and mute your mics.
Sir,
It's
better
getting-
to put in chat box, sir.
Okay, all of you, please. So, please wait, sir. Please wait, sir. Dear participants, those who are having doubts, please post in the Q&A box. Sir will clarify your doubts. Because of the huge participation and some disturbance in the audio, please post in the Q&A box. Sir will clarify your doubts. On chat also.
Karnakar sir, how many participants are there?
Now there are more than 280, sir.
280, right.
280 participants are there.
Mostly college time is over, they will be leaving.
Yes, sir. Yes, sir. It is up to 4:30, but many participants are eagerly waiting, sir, actually, for your
Thank you.
lecture.
Thank you.
It's more interesting. So,
No
So lot of
questions in
data is
the Q&A
available. We
box,
can.
sir.
Yes, sir.
thank you, one and all. Thank you, one and all, for your good response and valuable support. Expecting the same cooperation for the remaining sessions. Today's session concludes with a vote of thanks by co-convener Dr. T. Srinivas Rao Garu.
Good evening to all. A special thanks to our management, principal sir, and HOD sir for their valuable messages and constant support. Their guidance and encouragement have played a key role in making this session a grand success. On behalf of the Department of Mathematics and the participants, I would like to sincerely thank Dr. Bhaskar Babji sir for his valuable presentation today. Many of the techniques used in cryptography are based on discrete mathematical structures and a number theory. Some of these methods, such as modular arithmetic and linear algebra, were used even before the computer age. Today, encryption has become a highly specialized field involving complex, non-linear crypto systems that are so advanced that even powerful computers might take months or years to break the encryption. In today's session, Dr. J. Bhaskar Babji sir introduced a new combinatorial technique for encryption and decryption numbers using labeled graphs and the residue modulo class Z3. We are grateful to him for sharing his insights on graph techniques for cybersecurity. Despite his busy schedule at the university, Dr. J. Bhaskar Babji sir kindly accepted our invitation and delivered a wonderful talk. Thank you very much, sir. Today's session has been enriching with Dr. Bhaskar Babji sir presentation on graph techniques for cybersecurity, which has inspired new ideas among the faculty members and will help to strengthen their research skills. Dear participants, feedback link was shared in the WhatsApp groups and in YouTube link also. Please fill it and submit before 6 p.m. today. Thank you, one and all.
So, Bhaskar Babuji, sir, please bless us in the same way for our coming endeavors, future endeavors.
Yeah, sure, sir. Sure.
Thank you, sir. Thank you
very much. Thank you very much. Thank you. Bye.
Sir, thank you, sir. Thank you, Babji,
Thank
sir.
you, Karnataka. Thank you, TS sir.
Thank you, Bhaskar Babji garu.
Thank you, all colleagues.
Thank you, sir.
Thank you. Bye. 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 Bye.